Okay na? Okay, so isomerism and cycloalkane. So this is cycloalkane, pero different siya na type of isomerism. This is the cis-trans isomerism. Okay, but before we discuss this one, okay, ang difference ng gianid class, constitutional and stereoisomerism. Sa constitutional, there is a difference in the connection of atoms. Right? Sa stereoisomerism, there is no difference in the connectivity, but there is a difference in the orientation of the molecules. I'll give you an example. Hands, your hands. Okay, let's take a name. The connection of your thumb, pointer, middle, ring, and pinky is in that order. Right? If I have to change this one, pinky, ako'y maliit the ring, and then thumb, butang ako the ring, that's constitutional isomerism. Wala nag-change akong hands. That same components. Pero different lang ang connectivity. That's constitutional isomerism. Okay, say, balik na sa normal hands. Normal hand, right hand, left hand. All have the same connection, meaning the order of connection. Thumb, pointer, middle, ring, pinky. Thumb, pointer, middle, ring, pinky. Pero let's try to superimpose. Same ba siya na hands?
Same.
Same siya ng hands, pero how about the orientation of the hands? Dili. Because in this hand, natili ang thumb. In this hand, natili ang thumb. Okay, so dili siya magka-tugma. Mirror images of each other. Okay, so that is one example of stereoisomerism. There is no difference in the connection of atoms, but there is a difference in orientation. And one type of stereoisomerism ay player.
Yes, sir.
Init, sir.
Ay,
Init.
Babay. One type of that is one type of stereoisomerism. Another type, basta kay class, kaya nila dun sa stereoisomerism, there is no change in the connectivity, only the orientation. One type of stereoisomerism is the cis-trans isomerism. Okay, tanawan niyo sa class. This is dimethyl cyclopentane. Okay, this is dimethyl cyclopentane. Diba? Pentane, cyclic, so cyclopentane, 1, 2, dimethyl. Dua ka methyl. Diba? Okay, I will get this one, and then ibutang ako siya dito. Nabay change sa connection? Actually, wala. Because this is still connected to this carbon. Pero there is a change in the orientation of the carbon. Kanina, same side siya. Diba? Same side. Ang siya din nga side. Pwede po siya balihon. Hala, sige. Same sa baba. Okay, ang tawag galing na isomer, cis isomer. Cis. Same. Cis 1,2 dimethyl cyclopentane. We don't change the connection, but we change the orientation. Ibutan natin sa baba. Okay, different side. Ang isa nasa baba, isa nasa taas. Trans ang tawag na. That's trans 1,2 dimethyl cyclopentane. Okay, unsa may iyang significance? Again, different structure, different properties. Another thing, okay, na dapat ninyong mabalaan is important ang cis-trans isomerism because we cannot rotate the structure of cyclic alkanes. Okay, ako ipakita sa inyo na if this is a simple alkane, okay, this is alkane, right? Right? Alkane siya, di ba? Di ba? If i-rotate na ko siya, ma-rotate na ko siya. Diba? Kani, ma-rotate na ko na ko. There is freedom in the rotation pag alkane. Pero once naka-structure siya in such a way na naka-cyclic siya, okay? Hindi na siya rotate. That is why we have to emphasize whether the 2 dimethyl is in the same side or on the different side. Okay? Kuha. So again, kung same side, same tawag sa lahat. Cis isomer. How about kung different sides? Trans isomer. Simple lang kayo sa tanawang sa figure class. Why? Now, same side ang methyl, same side ang hydrogen. It's cis. different side ang methyl, different side ang hydrogen, that's trans. Any questions sa cis trans? Any question? Nasabtan? Nakuha? Again ha, there is no difference in the connectivity, only the spatial orientation. Mabitaw ang spatial, isomerism ang term yan. It's orientation in space. Stereoisomers are isomers that have the same molecular and structural formula, so same connectivity, but different orientations of atoms in space. Ayun yung kupiyahan na siya sa book. There are several types of stereoisomerism, one of which is cis-trans isomerism as shown kanina. And cis-trans isomers are isomers that have the same molecular and structural formulas, but different orientations of atoms in space because of restricted rotation about the bonds. Again, because of the restriction of the rotation, because of the cyclic nature of this cycloalkane, hindi siya makarotate. So, your trans cannot really change into cis. There should be a chemical reaction to change the cis to trans. Wait, nakuha ninyo? Class, I need your answers. Nakuha ninyo? Awara? Patumunta mong cyclo-creative. Okay. Again ha, because of the ring structure, we cannot really rotate. Tanaw ang cis, di ba cis siya? Pwede pa natin siya with rotation, change to trans? No. It requires a chemical reaction to change this cis. Tanggalon sa nato sa isang carbon, inibalin din trans. And because we need a chemical reaction to change cis to trans, they are basically the different chemical compounds. Ba? If we need to change, if we need a chemical reaction to change one isomer to another, then that is basically a different chemical compound. Kaya kung mag-rotate lang natin siya, class, di naman ta mag-cis-trans isomerism. Kung ma-rotate lang natin siya, hindi man. Okay, so, different ang cis, ang trans na configuration. Kuha? Kuha? Okay. So, what are the properties of alkanes and cycloalkanes? Physical property. Okay, let's go back to your discussion sa polarity. Ano man ang polarity sa inyong hydrocarbons? Polar molecule or non-polar molecule? Hala. Okay, ina ng pamudaan. All hydrocarbons are non-polar. Non-polar dyan siya. Okay, because of the tetrahedral shape of, because of the presence of the hydrogen all around, non-polar din siya. Okay? And because it's non-polar, it's insoluble in water. Why? Water is a polar solvent. So, di na siya ma-dissolve ang mga hydrocarbons sa water. And sige, try nyo, butane. Try nyo mix with water. It cannot mix with water. Okay? But, of course, because they are non-polar molecules, they are soluble in non-polar solvents. So if you have, let's say, gasoline, which is a non-polar solvent, kaya na niya mag-mix yan. In fact, one of the, are you familiar with octane? Nadoon yung octane gas, nagpagasolina mo. Nanay octane rating, di ba? Nagpagasolina. Basta-basta ko yung kalibutan ka sa interrupt mo sa iya, ha? Pagasolina mo na octane rating. Ano man, naisagol na octane ang gasolina. Why? Octane is soluble in gasoline because gasoline is a non-polar solvent. How about density? For the density, less, anali siya sa soap. The density, less dense than water, yun na siya. Okay, less dense. Class 1 is density. Okay, given the same volume, let's say we have 1 liter of methane and 1 liter of water, methane weighs less. So less dense siya. Mas gaan siya ba, given the same volume. Given the same volume of octane and same volume of water, octane should be lighter. Okay, so less dense siya. Okay, and because it's less dense, it should float on top of water. Another physical property is the boiling points. And again, as a rule, the longer the carbon chain length, the higher the boiling point. As explained kanina katong, the higher the chances of weak van der Waals interaction. Okay, although weak siya, Daghan mag-interact. So, stronger gyapon siya relatively speaking. Pero, pag daghan ng branches, the boiling point decreases. Okay, mas compact naman siya. Okay? Now, let's look at chemical property. Class pro tip, whenever you study about this, importante yung chemical property. Know the name of the reaction na pwede sa alkanes. Know kung unsa ang reaction, and please know kung unsa ang products. There are two reactions that can be made from alkanes, combustion and halogenation. Combustion class, all alkanes and cycloalkanes are flammable. And combustion products are always carbon dioxide and water. Iman ilan dyan siya naka-render. Class, you should always know that combustion, sige na combustion class? Combustion is, sa Bisaya. Combustion is magsunog. Diba? Always think of magsunog as rapid oxidation. Rapid oxidation na dyan siya. So it makes use of, saan siya? Pagpula, oxygen. Oxygen gas siya. Double bond. O double bond. O oxygen gas. So in every reaction, or combustion reaction, there is always the use of oxygen. So example, let's burn methane. Okay? Let's burn methane. Flammable man dyan ang methane according to the chemical property. All alkanes and cycloalkanes are flammable. But what happens now? Okay? Itanong sa inyo para mas appreciate. By the way, before we do this, share na lang kung naitapos ako kanina. I tried to perform the combustion reaction of methane using these ball and stick figures. But it turned out na nag-confuse ko kay ilan ay kabuk oxygen ang kailangan na ko para ma-burn ang CH4 of methane. CH4 plus oxygen in the presence of heat. Burn man nato. It becomes, let's say, products, carbon dioxide and water. Okay? Kailangan sa natin i-balance before pakita din kung saan siya. So, we have to know how many oxygen, how many carbon dioxide, blah, 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 and so on and so forth. Okay? So, how to balance na segue na siya sa discussion. So, CHO, pila ka carbon here? 1. Carbon here, 1. Hydrogen, 4. Hydrogen here, 2. Oxygen, 2. Oxygen here, 2. 1. Okay. Balancing equation class is just a puzzle. Style of ana is to analyze, okay na kang carbon, balance na, hydrogen wala pa. 4. Hydrogen 2. So, para ma-equal siya, 4 hydrogen here, 2 lang dire, multiply this by 2. And because you multiply the hydrogen here by 2, multiply na lang natin yung 2. Tingnan naman, pagpupuntan ng 2 nila, 2 times oxygen, right? So, okay na ka hydrogen, 4, 4. Dili na lang, oxygen, duha ka oxygen, So 4, then 2. So what to do? Minus 2. So balance na siya. Okay? So, in order to demonstrate, kailangan din ako duha ka oxygen molecule and 1 methane. So, ito siyang So, methane. Itong sindihan. Hindi siya oxygen. Ito siya. Ito siyang carbon dioxide. Okay, this is carbon. Tanaw natin yung sign. Okay, carbon dioxide. And pila pa water? Sa? Dua. So, dua ka water, carbon dioxide. Sunog na methane. Okay? Ano siya ang products? Carbon dioxide and water. So again, the general formula is alkane plus oxygen, it becomes carbon dioxide and water. Next, we have halogenation. Sa halogenation class, hindi na ko magamit ng volume stick, medyo makalangan ng time. But in halogenation class, hydrogen atoms are replaced with a halogen. Once again, may example sa halogen. Atong group 17, group 7A, your chlorine, your bromine, your fluorine, your iodine. Okay, so an example of this would be, let's say, okay, gamit na tag pinakasimple, no? Methane lang yapon. Okay? If you add, let's say, chloride gas, in the presence of heat or light, okay, it becomes, ang isa ka hydrogen, matanggalan siya hydrogen nila, replaced with chlorine. So, asa na padulong ang hydrogen dili nga na-replace? The hydrogen combines with the remaining chlorine. It becomes acid. Okay? So, the general formula is RH. Pag sa ng RH class, that's your hydrocarbon, your alkane. Plus X2. X2 would be your halogen. Okay? In the presence of heat or light, it becomes, kung siya tawag na doon sa RH, haloalkane. 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 Plus a halogen. Hydrohalogen. So, ano siyang products? Yes, halogenation is... Are you still with me?
Haloalkane, sir, tapos halohydrogen.
No, hydrohalogen.
Hydrohalogen.
Class, ang akong gina-discuss nila are the possible chemical reactions that could happen to alkane. The first one is combustion. Kaya di ba, sunugon man nato ang methane, ethane, propane, butane, masunog man siya. O na siya, nasabta na ng combustion.
Yes, sir.
Sabta na?
Yes.
Say products of combustion. Carbon dioxide and
Water.
water. So how about halogenation? Sa halogenation, we have an alkane. You react with halogen. O, dili tanaw. Alkane plus halogen. Halogen man di ba?
Yes, sir.
Sabta na halogen siya. Kani alkane di ba? Ang makita mo lang sa halogenation class, in the presence of, this is the catalyst, in the presence of heat or light, one of the chlorine will replace the hydrogen. Now, replace. Kasi may kagunan karon. Ay, siya yan. Ang kasi tawag na ito, ani. Imbis nga alkane, this is haloalkane. Now, kung sa'yo itabos sa hydrogen, nag-replace ni chlorine, the hydrogen will join with the remaining chlorine. Hydrochloric acid.
Isa rin na siya ka-formula, sir.
Actually, pwede ta mag-replace ang chloride gas with bromide gas. Basta kay for as long as halogen siya.
Ay, ano, sir, ba ang kanang hydrogen na ni-pair sa isa ka chlorine, connected lang na siya sa haloalkane.
Kani?
Yes, sir.
Kani chlorine?
Kanto dito, sir. Connected na na
Kani?
siya.
Sorry. Sige, akong klaro na the product is haloalkane plus hydrochloric acid. Hindi siya connected. It's another product. Pura lang nag-change ba? Diba? Chlorine will change the hydrogen. Yung isa hydrogen will join together with the remaining chlorine. Pero ang general formula na would be this one. So, analyze this. That says alkane, that represents alkane, RH. Kasabot na ng RH class ba? Kani ang R. Kaya ang iyong concern na would be the H lang ba? And that H would be replaced by, okay, this R, then chlorine. X, RX na siya. Instead of RH, RX na. Because X represents your halogen. Okay? And from X2, ngayon mo na siyang HX. Kani siya, HX. Or just replace the chlorine with X. Oh. Diba? So, RH, ano ako ba siya X? RH plus X, 2, heat or light, it becomes RX plus HX. Just replace X with halogen and your RH with any alkane.
Pero may tanong sir, ang halogen, permi na siya ito ka.
Yeah! Very good question. Because remember, pila man ang valence?
Because
7, di ba? It always forms a single bond with itself. Single completed bond. So for one, as a gas, diatomic dyan na siya ang halogen. Chloride gas, halogen gas. Saan mo i-laser? Any questions? So, masya combustion halogenation. Stop sa